Okay, now we come back. We do it again. We delete v.txt and we execute this program. It's recording. Yes. We execute once. Okay. So so we see v.txt and this is its content. Okay, which is correct. Now we keep v.txt intact. We did not change anything. Now we execute again. Okay? Now when we open v.txt, okay, we still see the same thing. Okay? Now we supposedly we take out average. Take out average. Okay? Take out average. Which however we would like to take out. Okay? And we change it v.txt into this guy, into this something like this. Okay? So v.txt into some kind of message. Okay? Now we execute the program again. Now, regardless of the content of the formal v.txt, after we execute this program, the v.txt will be erased and then rewrite everything. Okay, so we got a brand new v.txt. Okay, or now this time we delete one line. Okay, and save it. So v.txt only got one line. And we execute. Okay? And we compensate v.txt. So with wmod, the first thing when we open, it will erase all the stuff in the file. Okay? You got a brand new empty file. Okay? So when you write, you will write from the very beginning of the file. Okay? Now, supposedly we change wmod into amod, appending mode. Okay? As I mentioned, appending mode means incremental. Each time when you open the file again, it will not erase previous content. It will write something starting from the end of the current file. So currently, v.txt, we got finite of information. Now we come back our program. We open v.txt as appending mode. Okay? What we get is we execute once. Okay? On the screen you see the same stuff, but inside v.txt you got 10 lines. Okay? And what are these 10 lines? The first 5 lines is the previous execution of the program. And the last 10, not last 5 lines, is the latest execution of the program. It will write the information at the end of the previous version of the text file. Okay, so this is the information append to the previous file. Okay, now supposedly you run this program again. You're going to run again. Okay, the stuff go on screen is the same, but we open V again. You see 15 lines. Okay, the reason is the same. It will append stuff at the end of the file. Okay, now can we run this program again? Sure, as many times as you want. But what you will see, the b.txt is keep increasing. Okay, 5.9, 10.9, 15, 20. Currently you have 29. But each 5.9 is repeated. Okay, they are the same because you are running the same logic. Okay, just repeat, run it again. Okay, you got in the b.txt you have 25.9. Okay, and each 5.9. So this 5.9, this 5.9, this 5.9 is identical to. Okay, so this 5.9 is identical to this 5.9. Okay, it's identical to here. Okay, so we save this program as 01.01d. Okay, ex16-01d. Okay, now, so before we continue, I'd like to mention one thing is that either scanf or fscanf. Change again, scanf or fscanf. You guys should know the difference. The difference is fscanf start with file point and then with a double quotation with a string inside. Now, supposedly you have an integer variable called a. Okay? If you want to get an integer, you should ampersand a or fscanf the same percentage d. You should ampersand a. Now, if you want to get a string, a character, char b 100. You can use percentage s or percentage s in both scanf or fscanf, the same. What you should have put is ampersand b or just b. The answer is just b. You don't need ampersand because scanf and fscanf take address. Okay? Address is important. If you want to put something into a variable, such as a variable here, you need to ampersand a to take the address of a variable. But if you are a character array, we mentioned before, what is a character array? Is a b, which is a character pointer. And then you have a b0, which is a character, and a b1, which is a character, and until b99, right? and also a character. Now we say that B is what? B is a array name. And it is also a pointer of what? A character, char pointer. When you initialize a character array or declare a character array like this, operation system computer will do is allocate a memory space like this. Okay? With 100 char, totally you have 100 char. And a char pointer, which is what? Is 8 byte. When you are 64-bit operating system. Okay? And the initial value of this B character pointer, I should not say initial value, the constant value. Because B, you cannot change its value. B0, okay. B1, okay. B99, okay, you can modify the value, but B, you cannot change its value, which is an address. And the address, by declare this char array, its address will set to B0. Set to B0's address. So it point to B0. If B0 is located at 1010, then here is 1010, right? And this value we cannot modify at all, okay? Because once you modify the value, you will lose the connection between this 100 char. Okay? This is the address is the only way you will be able to get this 100 char. Now, why B you do not need this ampersand? Because B is already a pointer. Okay? So B is already a pointer. When you get percentage D, you need ampersand A. When you want to get a string and put into a char array, you need percentage S format. And here, you should give a char pointer. In this case, we give it the char array's name or char's pointer B. Okay? So scanf and fscanf. Here, you are starting from getting one character at a time, and the first character put it B0, second B1, third B2, until the last character, you will put the backslash 0 to end it will mark the end of the string. Okay? What is a string? The string is a sequence of character. Okay? So this is I need to mention before we proceed to the next topic. Okay? Now the next topic we like to talk about is structure. Okay. Now, what is a structure? Structure is a user defined data type. Now, system data type equals system data type equal. We're already very familiar with int, float, okay, double, and char, okay, and also you can see a modifier called unsigned, okay, unsigned, or long, short, okay, this kind of modifier of the data type. But what is structure? It's a user-defined data type. In C, we treat it as a data type, okay? Just like the data type we see so far, int, float, double, char, okay? Now, to define a data type, you should give a name, okay? This name, to name a structure, the naming convention is the same as variable function. So you can see it as or function, okay? So you can see it also as an identifier, okay? And char we get in this struct, okay, which is a reserved word or keyword for C language. So struct, let me show you an example. Struct, then we should give a name, okay, normally, okay. In C, we can also give an unnamed struct, but maybe I should skip this part. But so far, maybe you just keep in mind that a structure should give it a name, okay? Now struct, then the name, structure name, okay? Suppose we give it, for example, student. Crazy again. Okay, so this is identifier, okay? Just like variable name. You can give any name you want, okay? But before student, we have a reserved word, keyword called struct, and all in small case, okay? No capital case, please. Then we have pair a big bracket. Now, one more very important reminder. At the end of this right big bracket, you should put a semicolon. Please. Again, you forget to put semicolon here, I will guarantee compiler will give you a tons of error message. So keep in mind, you should put semicolon after the right bracket. And this whole thing is to define a structure, to define a new data type. And you give it a name called student. This student is the structure type's name. It's a user-defined data type, okay? It's a structure called student. Now, within this structure, you can define so-called data member. Okay, so you have a member called name, which is say 10 char, and then you have a integer array or grade is int with size of 3. Okay, now we see this simple data structure. Now we just type this, define this user defined data structure into our program. Where you should put this, the location is a structure definition is an independent block. Is independent. Okay? So you should independent of function or global variable. So in here we are going to define a new data type called or a structure called struct called student, and then okay, and Visual Studio 2017 is very friendly. It helps you put a semicolon already. Okay? So in the other version of the compiler other version of interface, other programming interface may not be so friendly to help you put a semicolon. But in Visual Studio 2017 will put semicolon automatically. Okay? Now, in student data type or student structure, we have two data members. One is child. The name is the first data member. And this data member is a character array and code name. And then an integer array called grade with size of 3. And say height, we use double. Okay? And we say weight. Okay? A sensitive topic. Okay? Or even more sensitive, age. Okay? Okay? Now, in this structure, student, we have 5 data members. One called name, one called grade, one called height, one called weight, one called age. Now in the you can define an integer variable by int I. So in memory, you will have a space preserved for an integer variable. And you can save an integer in this memory space. Now, this int can be replaced by a struct student. The role of int is the same as the role of struct student. This is a new data type. And we can define a variable called s, just like we can define a variable called I. We can define a variable called s. So by declare something like this, in the memory space, you will have space reserved for s. And S will occupies this location. And how big is this location? A is a short student. Okay? And how big is this location? How big? It should have a 10 byte, at least 10 byte for we have a S dot name. This location will have a 10 byte, 10 character, okay? Because name is a 10 character array. And then we have a grade. So this part, change color. Okay, this part. We have a 3 integer, which we can call it S dot grade. Okay? Then the following we are going to have 3 integer. Okay? The first one is S dot height and the S dot weight and the S dot age. Okay, and each one of them is integer. Each one of them is int. No. Okay, I forget. I should come back to what I type. Okay, 2 double and 1 int. Okay, so come back. So 2 double. The first one is double for height, and the second one is double for weight, and the last one is for age. Okay, the last one is int for age. So totally, S will contain 1 data member, 2 data members, 3 data member, 4 data member, and 5 data member. Okay? We have 5 data member. And the next question is how we are going to use this 5 data member. Maybe we should first answer how big is the S? How big is the structured student? We know int will take 4 bytes, right? And how many bytes will be taken by struct student? How many bytes will be taken by S? Now we can do a roughly computation is that 10 character, 10 byte, and grade, we have 3 integer array. So 3 times 4, because each int will have a 4 byte, right? And double will have a 8 byte, double 8 byte in a 4 byte. So let's sum it up is 20, my math is not good. 16 and then 4. So I said 42, right? So it should at least 42 byte, which is kind of big, right? But let's see. In here, we before we go into a.txt and b.txt, maybe we should first comment it out to take out the noise of the example, because we will come back to use a.txt and b.txt again. So before we go on, we commented out this program. Now we print F size of short. No, maybe we just print two integer for saving some time. So we kind of late. Okay, the first one is size of short student. Okay, and the second one is size of S. So now to define an integer, we can type inti, right? Now to define a student short student variable S is a short student's variable. Okay, so you can understand what it means by this statement. You should be able to understand this statement also. Okay? Now in here, we just print out this user-defined data type or structured student. Okay? And to see how many bytes it will require. And this is size of S. Okay? S is a variable of short student. Okay. Now let's see what we got. Take out this duplicate define of I. Now rebuild. We got a bunch of warning. Let's just ignore them for now. 48. Okay. The math we do is 42. Right? And 48 is obviously bigger than 42. The reason, honestly speaking, I don't know, is inside the operating system. It may be used for internal purpose of the compiler, okay? But knowing the size of a structure will not affect how we use it, okay? So I just want to mention a structure will occupy a larger space, okay, of memory location. Okay. Now, what I'm going to do now is that we take out this, and then let's see how we use variable S. S with a data member called name, right? And we can use in S.name to specify the data member name, which is belong to variable S. To do this, you should type S.name, okay? And S.name, to use S.name is the same as using a char array. So you can copy Robert. Okay, you can call in function string copy. Okay, you can do this perfectly. Okay, to do this, and you can s.grade 0 put 100. S.grade 1. Okay, and put it 95. S.grade 2. Right? You go to 80. Okay? Now, you can do the same thing. S dot age is 20. Okay. S dot weight is 55. Okay. 0.5. Okay. S dot height. 162.5. Okay, this you can do. Now, suppose you have another student variable. Now, to use this S dot name, to use it just as a regular, regular character array. So you can print percentage S, and grade percentage D, and the grade, okay, 1, and the grade. Just one more, say weight, okay, just print weight to save some time, okay. Now S dot name, use it just like a character array, and S dot grade 0. You can use it just like a regular variable. Okay. Now S dot grade 2. Okay, and then S dot weight. Okay, so let's just print this for these five variables value. Now, so what I'm going to illustrate here is that it is to demonstrate something strange. Rebuild. Okay, look at put a semicolon here. Rebuild. Okay. So what I'm going to illustrate here is that data memory is just like a regular variable. Okay, just like regular array. Then you can use it for a structured variable. It's a data memory. It's just kind of one level down variable. Okay, it belongs to a variable. Okay, a variable belongs to a variable. Okay, but the usage is the same as a regular variable. Now, I say this example, and let's take 10 minutes.